Hello, today's lesson is going to be on relations and functions. You are going to learn what a relation is, what a function is, how they relate to each other, and how we're going to use them this year. Let's start out with the most basic, a relation. A relation is a mapping or pairing of input values with output values. Very simply, it's just your x's and y's. This x maps to that y. You can see this in the form of a t-chart with your x's and y's. Sorry about that, my stylus is not working today. You have values that map to each other. That is a relation. The set of all x values is called the domain. The domain, that's also your input. These are the values you put in. Easy to remember. Sometimes we also refer to these as our independent variables, and we will do a little bit more on this later. The output, or the y variables, is your range. After we put in a set value, we get out a set value. We're going to move on to functions, and what I want you to remember is all functions are relations, but not all relations are functions. It's very similar to a square and a rectangle. All squares are technically rectangles, but all rectangles are not squares. A square is a special rectangle, a function is a special relation. The math definition says a function is a relationship for which each input has exactly one output. Or for each x value, there is one and only one y value. In other words, the x values cannot repeat and be a function. There are several different tests to this, several different ways you can see. The first of which is the vertical line test, and I'm going to show you some examples of that in a little bit. But what I want to do right now is talk about what exactly is a function. This seems to be an area where people know how to work with them, but they don't really understand it. A function is nothing more than the directions for what you're doing, or the equation. Think about it this way. A function could be something like a magic machine. If you put something into the machine, and what we put in would be the input, or the x value, and then something happens inside the machine, this is the function, the directions, the recipe, if you will, and something comes out the other side. The output comes out. The output is your y value. The something the machine does, that's actually the function. To put this in a way that might be easier for you to understand, think of the function like a recipe. You have all the ingredients. Ingredients are your input. Your recipe tells you how to make cookies, muffins, pancakes, whatever you're making that day. It tells you what to do with your input. After you do that with your input, you get a specific output. Now, to be a function, though, for each independent value you put in, there must be a specific output. So let's start simply and just see if we can see if this is a relation or a function by looking at ordered pairs. In this set of ordered pairs, -4, 3, -2, 1, 0, 3, and 1, -2, and -2, -4. What are the domain? What's the x values? I'm sorry. X values. These values are my domain. What are the y values, or the outputs? These are the y's, and we can list those. Sometimes we put them in order. That's just an organizational thing. It is probably easier if you do. It's not necessarily wrong if you don't. Now, to see if it is a function, look at your values and remember the x values cannot repeat. And if you want to make a note of that for yourself to help you remember, the x's cannot. So let's look at our x values. What do we have? -4, -2, 0, 1, and -2. Do the x's repeat? They do. -2 is available twice. Notice right here I have put the values in the table. These are our domain values. These are our range. Again, we're looking to see if the x's repeat. We have a -2 and a -2. That would mean this is not a function. You've also heard of the term mapping. Mapping is connecting an x to a specific y. So in this case, -4 maps to 3, -2 maps to 1, 0 maps to 3, 1 maps to -2, but if you look, -2 maps to 4. We've also said -2 maps to 1. So that means each of these has two values, therefore it cannot be a function. Another example using just a table. Look at the table on your right. Your domain values or your x values are -2, -1, 0, 1, 3, and your range or your output values are all -4. Is this a function? Ask yourself, do the x's repeat, or do they all map to their individual number? -2 maps to 4, -1 maps to -4, 0 to -4, 1 to -4, and 3 to -4. Everything has its own partner. Now, what if we wanted to graph this? Very roughly, we have the point -2, -4, put that right there. We have the point -1, -4, put that right here. The point 0, -4. We have the point 1, -4. And then we have the point 3, -4. So what this gives us is a horizontal line. Now, when working with a horizontal line, we can do the function test using something that's called the vertical line test. And the vertical line test is visual and very simple. And what it says is that if you draw an imaginary vertical line through the graph at any point, it crosses the graph only once. Just once. Not the axis, but the graph itself. So let's check this on our graph. So if I drew an imaginary vertical line, crosses it one time. I could draw it right here. Still crosses it one time. Therefore, this relation is indeed a function. We can see that by using the table. We can see that using a graph. Using just the vertical line test, let's go through these graphs and see if they are functions or simply a relation. So in the first graph, drawing an imaginary vertical line, how many times does that line cross the graph? 0. Well, if I drew my line right here, how many times does that cross the graph? Just 1. Well, what if I drew it over here? Crosses once. And in reality, this line over here, even though we don't see the intersection, this parabola is going up and up and up to infinity, so they would eventually cross. So this one does cross the graph one time. That means it is a function. Let's look at this graph. It is a vertical line. Vertical lines are something that look like x equals a number. That's the equation for them. If you wanted to write that in a table, it would look like this. Our x value here is -2, and my y value could be 0. Another point could be -2, 2, and so on. Now looking at this one, if I draw an imaginary line, that one doesn't cross. This one does not cross. We're not talking about crossing the axis. We're talking about the graph itself. If I drew the line right here, not only does it cross it, it is on top of it, so it crosses infinitely many times. This is not a function. If you look at the table, you can see it as well. The 2's repeat. On our third line, it's another horizontal line, and as a quick refresher, this is in the form of y equals some number. So on a table, it's going to look like at x is 0, y is 3. At -1, y is 3. At 1, y is 3. So that's how it looks on a table. Imaginary line test, crosses once. Crosses once. You do not have to draw multiple lines. I'm just doing this to show you that at any line you draw, if it crosses it one time, it is a function. All right, let's look at the next one. We haven't quite got there yet, but this is what's called a cubic graph, something to the third. And if we do our imaginary lines, how many times do these lines cross? Let's recap what we've learned so far. In relations versus functions. In a relation, it's a mapping or pairing of x to y. The x's may repeat. In a function, it's also a mapping or pairing of x to y, but the x's may not repeat. And why does this occur? Because for each x, there is one and only one y. There's a specific y for every x. Functions can take on some specific forms. We can express them as tables. And we have our x's and we have our y's. These map to each other. We can use ordered pairs. That look like x and y. We can use a graph. And on a graph, we utilize the vertical line test to tell if it is a function, which is an imaginary vertical line that crosses the graph one time. But at the base of it all, what I want you to remember is a function is telling you what to do. It's your directions. It's the algorithm. It's the math you do. That's all it is. I hope this helped. If you have any questions, please see me and I will clear them up for you.